Major AI Agent Protocol Comparison: The Future of AI Interoperability. Interoperability is not optional in AI agents anymore. As we move toward building the next generation of multi-agent ecosystems, the ability for different AI agents to communicate, collaborate, and share resources seamlessly has become a fundamental necessity rather than a nice-to-have feature. The challenge facing organizations today is choosing the right protocol for their specific use cases. Each protocol offers unique advantages, architectural approaches, and operational characteristics that make them suitable for different scenarios. Understanding how these popular AI agent protocols work is critical for building scalable, efficient, and future-proof AI systems. Today, we'll explore 4 major protocols that are shaping the future of AI agent communication: MCP, Model Context Protocol; A2A, Agent-to-Agent Protocol; SLIM, Secure Low Latency Interactive Messaging; and ACP, Agent Communication Protocol. Each represents a different approach to solving the interoperability challenge. 1. MCP, Model Context Protocol, the universal connector for AI tools. Overview: the USB-C port for AI tools. Anthropic's Model Context Protocol revolutionizes how AI agents interact with external tools and services. Think of MCP as the USB-C port for your AI tools, a standardized interface that enables seamless connectivity across diverse systems and platforms. Architecture: Client-server simplicity. MCP architecture type: client-server. Discovery method: manual registration. Session management: session-aware or stateless, flexible. Transport protocol: HTTP, STDIO, SSE, server-sent events. Best use case: tool calling and resource integration. How MCP works: step-by-step process. Step 1. User interaction. User initiates interaction through the MCP client interface. The client can be any application, chatbot, or AI system that needs external capabilities. Step 2. MCP client processing. MCP client receives user requests and processes them. The client determines which external tools or resources are needed, handles authentication and connection management. Step 3. MCP host communication. MCP client communicates with MCP host using standardized protocols. MCP host manages connections to various external services and tools. Data flows seamlessly between client and host using structured formats. Step 4. MCP server integration. MCP server connects to multiple external services simultaneously, supports integration with popular tools like Slack, team communication and notifications, Dirkrant for vector database operations, Brave Search for web search capabilities, many other tools and APIs. Step 5. Response processing. Responses flow back through the MCP architecture. Client receives formatted responses from multiple sources. User gets integrated results from various external tools. Key advantages of MCP: standardized integration, provides consistent APIs across different tools and services, reduces development complexity from multi-tool integrations, enables plug-and-play functionality for new services, flexible architecture, supports both session-aware and stateless operations, multiple transport protocols for different use cases, easy to scale and maintain, developer-friendly, simple client-server model that developers understand, comprehensive documentation and examples, growing ecosystem of supported tools. Ideal use cases for MCP: tool integration platforms, applications that need to connect with multiple external services, AI assistant backends, chatbots and AI assistants requiring diverse capabilities, workflow automation, systems that orchestrate multiple tools and services, development environments, IDEs and development tools with AI assistants. 2. A2A protocol, multi-framework agent communication. Overview: breaking down framework barriers. The A2A protocol, developed by Google, has set a new standard for multi-agent communication by enabling seamless interaction across various AI frameworks and platforms. A2A addresses the critical challenge of framework incompatibility in the AI ecosystem. Architecture: centralized peer-to-peer. A2A architecture type: centralized peer-to-peer. Discovery method: agent card retrieval via HTTP. Session management: session-aware or stateless.
Transport Protocol, HTTP, or optional SSE. Best use case, inter-agent negotiation and collaboration. How A2A protocol. Detailed process. Step 1. Agent registration and discovery. AI Agent 1, using DeepSeek v3 model with Google ADK framework, registers its capabilities. AI Agent 2, using Mistral 8x7b model with LangChain framework, also registers independently. Agents discover each other through the A2A protocol discovery mechanism. Step 2. Capability exchange. Agents share their agent cards containing specs and models, supported tasks and operations, available tools and integrations, communication preferences. Step 3. Task initiation and processing. User sends requests to either agent. Receiving agent analyzes if it needs assistance from other agents. Initiates communication with relevant agents based on task requirements. Step 4. Inter-agent collaboration. Agents negotiate task distribution and responsibilities, share intermediate results and context, coordinate actions to achieve optimal outcomes. Step 5. Streaming and real-time updates. Supports both request and response communication. Agents can provide real-time updates during long-running tasks. Users receive coordinated responses from multiple agents. Key features of A2A protocol. Framework agnostic. Works across different AI frameworks, Google ADK, LangChain, etc. Enables interoperability between different model providers. Supports various programming languages and platforms. Intelligent negotiation. Agents can negotiate task distribution automatically. Supports complex multi-step workflows. Enables specialization and collaboration. Scalable architecture. Handles multiple concurrent agent interactions. Supports both small and large-scale deployments. Efficient resource utilization across agents. Ideal use cases for A2A protocol. Multi-expertise systems. Tasks requiring different specialized agents. Distributed AI networks. Large-scale systems with multiple AI components. Cross-platform integration. Agents built on different frameworks. Collaborative research. Multiple AI agents working on complex problems. 3. SLIM. Secure low-latency interactive messaging. Overview. Cisco's Internet of Agents vision. SLIM, Secure Low-Latency Interactive Messaging, is part of Cisco's ambitious initiative to build the Internet of Agents, a secure, high-performance network infrastructure designed specifically for AI agent communication. Architecture. Gateway-based transport layer. SLIM architecture type. Gateway-based transport layer. Discovery method. Routed via agent gateway with authentication. Session management. Stateless with encrypted sessions. Transport protocol. gRPC, HTTP2 plus protobuf. Best use case. High throughput secure messaging. How SLIM protocol. Network level process. Step 1. Agent registration. Agents register with the central agent gateway using secure gRPC protocols. Registration includes agent capabilities, security credentials, and routing preferences. Gateway validates agent identity and authorization levels. Step 2. Gateway infrastructure setup. Message gateway, central routing hub that manages all agent communications. Control plan, handles routing policies, security rules, and traffic management. Data plan, manages high-speed message routing and delivery. Step 3. Communication modes. SLIM supports multiple communication patterns. I/O agent gateway, request response messaging for direct agent communication. Runtime gRPC server host, streaming communication for real-time collaboration. Protocol abstraction, unified interface regardless of underlying communication method. Step 4. Dynamic message routing. Gateway analyzes message destinations and routing policies. Automatically routes messages through optimal network paths. Handles load balancing and failover. Maintains quality of service requirements. Step 5. Security and observability. End-to-end encryption. All traffic is encrypted in transit and at rest. Authentication. Multi-layered authentication for all participants. Observability. Comprehensive monitoring and logging of all communications. Policy enforcement. Dynamic security and routing policy application. Key advantages of SLIM. Enterprise-grade security. Military-grade encryption standards. Comprehensive authentication and authorization. Network-level security policies. Audit trails for compliance. High performance. Low latency with gRPC optimization. high throughput capabilities for large-scale deployments, efficient binary protocols, network-level optimization, scalable infrastructure, designed for internet-scale deployments, automatic load balancing and failover, geographic distribution support, enterprise-grade reliability. Ideal use cases for SLIM: enterprise AI networks, large-scale corporate AI deployments, real-time systems, applications requiring ultra-low latency, secure communication, government and defense applications, IoT and edge computing, distributed agent networks. 4. ACP, Agent Communication Protocol. Overview: IBM's Comprehensive Agent Framework. IBM's Agent Communication Protocol, ACP, provides a comprehensive framework for both online and offline multi-agent communication, focusing on modularity, flexibility,